Alright, hello everyone. So, in this video, I'm going to briefly and badly explain nuclear fission, like how a nuclear fission reactor works, using Minecraft. So, very basics of it is you take a hunk of uranium, which, for these purposes, has two isotopes, uranium-238 and uranium-235. The uranium-238 there's a lot more uranium-238 than there is 235. So, um, now mind you, you need the 235 in order to get any fission out of it. So, as a result of that, you must enrich the uranium using, well, not this, there's so much chemistry in it that Cody Don Reaver, I'll put a link in the description. He didn't enrich it, but he purified it and made it into like an actual physical ingot of uranium. I'll put that in the description because I think he re-uploaded it, and it might get my video flagged, but who knows. But anyway, so if when you watch that video, you'll notice at some point he makes yellow cake. In Minecraft, well, the mod I'm using, that's what you need. But um, I'm not super knowledgeable on how the enrichment works. But one way or another, you get enriched uranium, which has a higher number of 235, which has a higher amount of the 235 isotope. That is then gasified, in this case using um, fluorite fluoric acid, one of the two. It's gasified and turned into uranium hexafluoride. That is then fed into something like this, an isotope centrifuge, which takes the gaseous uranium hexafluoride and separates the 238 and the 235. Now, in this version, it just pumps the gas straight into a reactor, but in real life, what happens is it's formed into pellets. It's little itty bitty pellets that I'll throw on screen, and those, so many of those are put into one thing, and they're slowly lowered into a reactor in order to, um, what's the word I'm thinking of? In order to control or moderate how fast the reaction's going, because you don't want a reaction going too fast, and while a slow reaction is nice, it doesn't generate as much fuel as a fast one. But if it goes too fast, the plant could melt down, which no one wants. So, in this case, it's cooled by sodium, because there's something in the back I want to show you, but for most cases, it is cooled by water, as that's much quicker. Water acts as a mediator, meaning that it reflects the neutrons back, and it also heats up, and we'll show what that does later. But without further ado, let's activate a reactor. We have almost 2 buckets of fuel in there. Let's go. So immediately, you'll notice, that's pretty loud actually. Ooh, I'm not sure if you can hear me. Let's just turn that. Yeah, now you can probably hear me a bit too well. So as you can see, it's glowing a blue. That's called Cherenkov radiation. It's when light isn't actually going at the speed of light, because little fact that I don't think many people outside of nerd communities know, but light only goes at the speed of light in a vacuum when there's nothing slowing it down, when it doesn't have to account for, you know, wind resistance or shit like that. But in this case, because it's going, well, in this case, it's going through a gas, but in most cases, it's going through water. So it's much slower, meaning that it emits, what is it? It emits Cherenkov radiation, which is in this case, which is blue. for physics reasons. I'm not entirely sure. As I said, this is a bad summary, not a good one. So out the back, there is the reactor waste, which in this case is a gas going directly in the barrels, and you have the hot sodium. That is fed into this boiler here, which takes the superheated sodium and the water that I'm pumping into the nearby river over there, which is actually pretty accurate to what happens. They take something like, say, water from the ocean or whatever, and they just fill up reactors with it because you can't run out of the ocean. The ocean's for our purposes, the ocean's unlimited. So that heats it up and makes steam because yes, shocker, shocker, nuclear reactors, nuclear fission reactors, they don't generate energy. They generate steam, which turns a turbine, and that generates energy. Now the nuclear waste, as you can see, I'm just putting barrels, but in some countries, that nuclear waste, it's refined and reused, so there's much less unusable nuclear waste. Now, if you actually look at the nuclear waste, you'll see that there's a little number, 10 MSV per hour, or slash H. That's 10 microsieverts per hour. A sievert is a unit of measurement based in metric, I believe. It's a base 10. However that works, I'm not entirely sure. So that is, I'm pretty sure, a bad summary of how nuclear physics work using Minecraft and a rudimentary understanding of nuclear physics. Before I forget, the way this actually works is that it shoots neutrons. The way the way the fissile fuel actually is useful. The reason it's useful is because 235s are right at the cusp of being unstable, but not quite. So what happens is they shoot neutrons at it. That causes it to more or less just kind of blow up. And if it's uncontrolled, you get something like an atom bomb, like the Fat Boy, the Little Man, stuff that is used in World War II. But if you control it well, you get heat. You get a functioning nuclear reactor is what you get, really. And so, yeah, that's the end of the video. Have a nice day, everybody.